Okay, so welcome to the second video in chapter 2. We're going to be talking basically about a 5-number summary and a box plot. So in the first video, we talked about ways of measuring the center and the spread of data. So the center is the middle, a couple different ways of doing that. The spread is how our data differs from being in the middle. So that was standard deviation or variance. So now we're going to talk about the shape of the data. So a bit more of how does the data look? Not just sort of a one numerical summary of center or spread, okay? So there's something called the 5-number summary that we can look at to get a sense of the shape of the data. So given a data set, the 5-number summary of a variable consists of the minimum value, the first quartile, the median, the third quartile, and the maximum. So those would be the 5 numbers that might give us a sense of the shape of this data set. Now, the first quartile and the third quartile require some explanation. So first off, remember the median was the middle value of the data. If we arrange the data from smallest to largest, dead center was the median, okay? And in the previous video, we figured out ways of calculating that. Well, the first quartile is going to be the median of the values that are less than and equal to the median, less than or equal to the median. So we're going to take all the values up to and including the median, if the median is one of our data points, and take the median of that new data set. That's the first quartile, the 25% mark. The third quartile then is the median of the values greater than or equal to the median, okay? So take the median and everything above it, if the median is one of the data points, and take the median of that upper half data. Okay, and I'm going to do an example that will hopefully illustrate it. So that should probably be 4. Okay, so the data set, it's going to be the same one we used in the last video. I've got 15 values, 9, 10, 11, 11, 12, 14, 16, 17, 19, 21, 25, 31, 32, 41, 61. So who knows, maybe this is the number of cupcakes 15 students ate in a week. Okay, and we recorded the number of cupcakes. So 2 students both ate 11 cupcakes. All right. We're going to try and get the 5-number summary of this data set. So the minimum data set value is obviously 9. By the way, I've arranged them in ascending order. The maximum in the data set is 61. Okay, so I've got the min and the max. I've got the first and the 5th value in the 5-number summary. The median is the middle data set. So there's 15 numbers here. The middle one would be the 8th one, right? So that's the number 17. First, second, third, 4, 5, 6, 7, 8. So the median, y sub 8, y means I've arranged them in descending order. The median is 17. Okay, Q1, Q sub 1 is what we'll call the first quartile. And so I need the median of the numbers less than or equal to the median value. Okay, so here's the values that are less than or equal to that 17. 9, 10, 11, 11, 12, 14, 16, 17. So here's sort of my new mini data set, and I want the median of this data set. And if I look, there's 8 values. So I'm going to take the middle value between 11 and 12. So I'm going to take the average of 11 and 12, and that's 11.5. So that's my first quartile of this data set, sort of the 25th percentile spot. The third quartile, Q sub 3, that's where I take the top half of the data. So I go from the median on up. And again, there's 8 data values, 1, 2, 3, 4, 5, 6, 7, 8. So the median occurs between the 4th and the 5th of those data values, which overall are the 11th and the 12th of the 15. Okay, but anyway, I just look at the 2 middle guys, 25 and 31, and I take their average median. Okay, so there's Q1, there's Q3. So I've got it. I've got my 5-number summary: minimum, Q1, median, Q3, maximum. And that gives me a sense of how this data is shaped. I know where the median is, and now I see that the maximum is way further above the median than a minimum is below it. So I can kind of sense that the data here is kind of skewed, has a right skew to it, a longer right tail than left tail. Okay. All right. So then once I have the 5-number summary, I can also create a visualization of this, and that's called a box plot. Okay, ignore that sound. Right. So, and with this box plot, I'm going to kind of be drawing it while we go about doing it. Right. Good. I've got everything on there. Cool. Okay. So pause, copy it down, and then I'm going to start in, and I'll draw the box plot as you listen. Okay, so the box plot, it's a visualization of the 5-number summary. And I've got my 5-number summary from before, that last example. So I'm going to draw a box from the first quantile to the third quantile, so Q1 to Q3, and I'm going to place a line at the median. So here, I'll remind you that my data, my Q1 was 11.5, my Q3 was 28, my median was 17. So I'm going to place a box from about 11.5 up to 28. Make a nice little rectangle there, right? And then I'm going to place a line at the median of 17. So there's Q1, there's the median, there's Q3, okay? Step 2, this is sort of the lengthy computation side. I'm going to calculate, first I'm going to calculate the interquartile range. So that's the distance between the third and the first quantile, which I do, and I get 16.5. And then I'm going to figure out upper and lower caps. Now, to get the upper cap, I first need to figure out the upper fence. So the upper fence, by definition, is the third quantile plus 1.5 times the interquartile range. So in our example, I had 28 for the third quantile, 16.5 for my interquartile range, and 28 plus 1.5 times 6.5 gives me 52.75. And I'll do the lower fence as well. The lower fence is similarly defined. It's my first quartile minus 1.5, the interquartile range. I feel like I'm saying quantile versus quartile. These are quartiles because I've divided the data into quarters. Okay. Okay, so the lower fence is Q1 minus 1.5 times the IQR. My Q1 was 11.5. My IQR was 16.5. So my lower fence is negative 13.25. Yes, negative 13.25. Okay, well, now I've got the fences, I'm going to actually set the caps. So my upper cap, I'm going to place a cap at the largest data value less than or equal to the upper fence. And I'm going to call that the upper cap. So my upper fence was 52.75. And if you look back at your data, the largest data value less than or equal to 52.75 was 41. So I'm going to place a fence or a cap, sorry, at 41. So there's my upper fence. In the middle. I connect it with the line. Okay. You might also have heard these referred to as box whisker plots. All right. Now I need a lower cap. The lower cap is the smallest data value greater than or equal to the lower fence. So my lower fence was negative 13.25. And my smallest data value that exceeds negative 13.25 is my data point at 9. Okay. So I'm going to place a lower cap at 9. And then my third step is to plot the outliers as separate points. Now, 9 is my least value, so I've got everything accounted for, but I have one outlier that's not accounted for in my distance between my lower and upper cap, and that's the data point 61, my max. So I'm going to plot a single data point at 61. So this would be a box plot of the 5-number summary. And it's kind of showing you how your X values are in your data set are distributed. It looks like we've got a lot of them right in here. And then the other half of them are really kind of far more spread out. So the upper half of the data has far more range than the lower half of the data has. So I'm getting a sense of how this data is shaped.